So these ones here, we have a system of quadratic equations, quadratic in terms of x. So we want to be able to eliminate one of the variables by substitution. Now I could solve for y in either case, but both cases I'm going to end up with a fraction, which is maybe not ideal. Not a big deal, but it's not ideal. Here I could also notice that it's only an x squared and not x's. So it is possible to isolate the x squared and actually replace the x squared. In fact, that's what I'm going to choose to do. And the only reason I'm choosing to do this is to avoid fractions. I'm just going to try to avoid the fractional values here. So x squared is equal to 5y minus 2. And I'm going to replace it in that equation there. Okay, so there's my equation 2. So it's going to look like this. I'm going to do a like-for-like replacement. So I replace the x squared with 5y minus 2. I've achieved what I wanted to do. I've eliminated one of the variables, which allows me to solve this equation. In fact, this is now a linear equation. And I can solve for y, so subtract 2y from both sides, add 13 to both sides, okay, to cancel out the negative 6 and negative 7. So I end up with y equals 1. Okay, remember, it's a system. I do have to solve for x. So when I substitute it back, I end up with x squared equals 5 times 1 minus 2. X squared is equal to 5 minus 2 is 3. Remember to plus minus when you square root. So I get 2 x's. So my solutions look like this. Remember, these are two-dimensional solutions. So we have an x and y solution. So root x 1, negative root x, y equals 1. Okay. For this example here, now I could try to do the same thing, but the problem is I have an x squared and an x. So if I replace this x squared, I still have an x here that's going to be hard to replace for. So in this case, although I may end up with fractions, I might be better off substituting for y. Now, because we can do like-for-like replacement, instead of substituting for y, I'm going to just substitute for 2y, because I can make that into 2y. So by dividing that second equation by 2, x squared minus 1 equals 2y, I'm going to do a like-for-like replacement for that 2y. So I end up with x squared plus 2x plus 5 minus the 2y is replaced with x squared minus 1. And that's going to be equal to 0. Okay, so now I end up with a quadratic equation with only x's. In fact, because it's x squared minus x squared, it actually reduces to a linear equation. Plus 5 minus negative 1 is plus 6 equals 0. I can now solve for x. So x works out to be negative 3. Again, make sure that we solve for the y variable as well. And I can do that by plugging into this equation here. So I end up with negative 3 squared minus 1 equals 2y. This becomes positive 8 equals 2y. It looks like there's just the one solution at x equals negative 3, y equals positive 4. Okay, and we can graph this to confirm. And again, we should graph to see what's going on with these. And I'm going to graph, I'll show you the graph of Desmos the graph of this example on Desmos, so we can see how we confirm our answer. It is a bit strange too, because it's a quadratic. We kind of expected 2 solutions for x, but somehow they canceled out.